Question 32. Consider the following two problems. 1. Nearest neighbors. Given an unsorted array of n floating point numbers as input, return 2 of the numbers that are closest in value to each other. And question 2. Farthest neighbors. Given an unsorted array of n floating point numbers as input, return the two numbers that are farthest in value from each other. So nearest neighbors and farthest neighbors. And assume that you can only do 3 operations. Compare values in the array and identify the larger value. Compare the distance between the two array entries, in other words the absolute value of the difference between the two array entries. And then 3, swap the entries in the array. So each operation has 1 unit cost. What's the worst case running times for algorithms that solve the two problems? This is the kind of question that reminds us that we got to memorize our or have a good understanding of our time complexities for the different sorting. But basically, we all kind of know that we could sort this entire array in n log n, right? We all know that. So the worst case we can do is n log n for any of these things. So anything that's not n log n, we can toss that out. It ain't going to be it. In the case of the nearest neighbors, the ones that are the two closest, it's a little bit more complicated. Let me get back to that. In the case of the farthest neighbors, all we really got to do is put the lowest one in the first element of the array and the largest one in the last element of the array, and just go through all the numbers until and just keep on putting them in there. So basically, we can tell who the farthest neighbors are really easily just by keeping track of the minimum and maximum number in the array. So basically, if I go to this one, I pop it in here and go to this one, and if it's bigger, then I'll pop it in here. If it's smaller, I'll put this one in here and swap that one in there. So we can just keep the minimum and the maximum. We don't care about any of the ones in the middle. We just want to know the farthest neighbors. So this is basically is 1, 2, 3, 4, 5. Just keep on doing it till you get to the end. So that's O of n. And the other one, the nearest neighbors, that we can't do that because we have to check every single one of them to see which ones are nearest. You know, we can't tell by the index number which ones are nearest, so we're going to have to keep track of whether the 2 that we have in question are closer or not. What we'd have to do is basically sort the entire array and then go from item to item to see which one had the closest distance. So this is going to be n log n. So the answer is A, O of n log n for the nearest neighbor, and O of n for the farthest neighbor, and that's pretty much why.